Hi class, and welcome to our next video lesson. We're on 5-7. We're dealing with expressions that have rational exponents. So what this lesson talks about is, in math, there's different ways of writing the exact same thing. Such as if I just take the number 3.5. 3.5 can be written a variety of ways that mean the exact same thing. It's the same thing as 3 1/2. 3.5 and 3 1/2 are the exact same thing. As well as 7 halves. There's 3 different ways of writing that exact same number. The same is true of radicals and rational exponents. They're saying the exact same thing, it's just a different way of writing it. Here's what I mean by that. If we take the square root of 9, this is a radical, right? It's a radical 9, square root 9. We all know this to be the number 3. Now I can write this as a rational exponent. It's the exact same thing as 9 raised to the 1/2 power. If I raise 9 to the 1/2, I also get the number 3. Let me prove that to you. Using our calculator, if I raise 9 to the 1/2 power, or 0.5, I get the number 3. If I raise 49 to the 0.5 power, I get the number 7. If I raise 100 to the 0.5 power, I get the number 10. As you can see, raising something to the 0.5 power or raising something to the 1/2 is the exact same thing as saying, let's take the square root of it. It's just a different way of writing it. Okay? So that leads us into this. Right now I see an exponent that's rational. It's an exponent of 1/4, and I want to write this in radical form. So I want to see a radical sign in my answer. So here's how we're going to do this. This 1 right here, this always becomes our exponent. Exponent. Please write that down in your notes. This 4 right here, that always becomes your index. So x is our base, so when we talk about radical form, we're still going to have x being the base underneath the radical. The 4 is our index, so it's the 4th root of x raised to the 1 is our exponent. So our answer is the 4th root of x raised to the 1st power. So all we're doing here is rewriting these. Okay, it's nothing too difficult. We just got to get used to the form. So it's the 4th root of x raised to the 1st. Let's try number 2. This becomes our exponent. This becomes our index. So this is rational form. I want to change it into radical form. So my base number of 26, it's the 4th root of that, 26 raised to the 1st power. And obviously, oftentimes we don't write that 1 in there because it's assumed that anything by itself is raised to the 1st power. So it's the 4th root of 26. Let's take a look at number 3. It's slightly different. The same process remains in that this becomes our exponent, and this number 3 is our index. So it's the 3rd root of 27 squared. Don't leave it like this, so class, because we could simplify the 3rd root of 27 squared. If you kind of look at 27, 3 cubed is 27. So the 3rd root of 27 is 3. So I could basically take this 27 outside the radical, because the cubed root of 27 is 3. So I just took a 3 out, and this squared comes with it. And now the radical is gone. When I take the cubed root of 27, I take that out, and now I have nothing left underneath the radical because the squared sign comes with it. So what is my answer? My answer is 3 squared. And as we all know, 3 squared is 9. If this seems really fishy to you, let me prove it. It's 27 raised to the 2/3 power. We said it's the same thing as 9. Calculator, can you prove us right? 27. Raise that to the 2/3 power. And I press enter, and what do you know? We get the number 9. Okay, so we'll be doing more practice with this as we get on in our notes. It might seem a little bit odd right now, but hopefully as we get more and more practice, this will become second nature to you. Let's try the last problem on getting these into radical form. Our rule reminder says that if we have a power raised to a power, do we add, subtract, multiply? The answer is we multiply, and we get x to the 12th. So we have a power raised to a power. We're going to multiply 2 times 4/3, and we get x raised to the 8/3. Now that we have this, let's make this our exponent. Let's make this our index. So it's the third root of x to the 8th. The third root of x raised to the 8th power. Always think to yourself, I wonder if I could simplify more. If your index is larger than, if your exponent is larger than your index, you can reduce. So what we're going to do here is we're going to make this into 8 thirds. 8 divided by 3 is the same thing as 2 and 2 thirds. We talked about this in our video lesson the day previous to this. So 8 thirds is the same thing as 2 and 2 thirds. So I can take out an x squared. That 2 represents the x's that we can take out. I can take out an x squared. This right here is our index. We still have an index of the cubed root. And this right here is still our exponent on our variable of x that's left underneath the radical. So x squared. So the cubed root of x to the 8th is the same thing as x squared times the cubed root of x squared. And that is our problem. That is our answer for problem number 4. Notice how with this thing that we did yesterday in the previous video lesson, this is our exponent, the one in the numerator. This is the index, that's the number in the denominator. Look at how it's the exact same thing when we simplify these radicals. The index is in the denominator. The index is the denominator. The index is the denominator. When we simplify these fractions over here, the index is in the denominator. So we're consistent with all of those. Now we're going to go the other way around. We see radical form. We want to change this into rational form. So we want to get a rational exponent, which means writing it as a fraction. We still have our base. This number right here, this becomes the numerator. The index is our denominator. So the cubed root of y squared is the exact same thing as writing y raised to the 2/3 power. And there's our answer for problem number 5. Y raised to the 2/3. Problem number 6, there's an understood index of 2 right here, and there's an understood exponent of 1 right there. It's 23 raised to the 1st, and it's the square root of that. So 1, you are our numerator. 2, you are our denominator. So it's 23 raised to the 1/2. We're not going to have any radicals in these. We're going to have rational exponents or fractional exponents. 23 raised to the 1/2. Let's look at problem number 7. This 6 is raised to the 1st power. The x is raised to the 5th, and the y is raised to the 7th. So all of these become our numerators. It's 6 raised to the 1/3. Our index becomes the denominator. X raised to the 5/3, and y raised to the 7/3. So all we're doing here in this video lesson is we're rewriting these from radical form to rational form, or from rational form to radical form. So it's just like giving something a different name, such as 3.5 is the same thing as 3 1/2. They say the exact same thing, it's just a different way to write it. Here's decimal form, here's fractional form. Same is true of rational form and radical form. They say the exact same thing, it's just a different way of writing it. Let's try problem number 8. So 27 raised to the 1/3, a raised to the 2/3, and x is raised to the 1/3. This would be our answer if we can't reduce anymore, but hopefully some of you see, well, Mr. Berge, the cubed root of 27, we've already talked about that, that's the number 3, which you're absolutely right, or 27 raised to the 1/3 is 3. Let's prove that in our calculator. 27 raised to the 1/3 power is the number 3. So that 3 can be more, that's the simple form of 27 raised to the 1/3. So it's 3 a to the 2/3 x to the 1/3. And there's our answer for problem number 8. We'll get more practice on that when you come to class tomorrow.